In this video, we'll show the work being done at Alias Wavefront on a new experimental GUI paradigm. This paradigm is based on two-handed interaction techniques that have been specifically designed to support the tasks involved in creating digital art. Our designs have been inspired by observations and comments from professional graphics designers. In a traditional studio, graphics designers use two hands for many tasks. Usually, the non-dominant hand is used to move and hold the artwork in a comfortable position. The non-dominant hand is also used, very unconsciously, to switch tools fast and without loss of focus or concentration on the piece of work. Finally, some tools are bimanual, requiring both hands, like rulers, French curves, and masking with an airbrush. In an attempt to emulate and explore these types of fluid interactions, we developed an experimental GUI prototype called T3. T3 focuses on three design goals. Number 1, maximize the amount of screen used for artwork. Number 2, minimize the amount an artist must divert their visual attention from the artwork. And 3, improve the quality of input in terms of expressiveness and comfort. We call the prototype T3 because it's based on using two hands, tablets, and tool glass technology. The first thing you'll notice is that we are using two tablets with two special puck devices. Each puck has two sensors which allows the puck to detect rotation. Ideally, we would like to use only one tablet, but technical limitations force us to use two. Although each puck has 4 buttons, our design only requires one button per device. The basic model is that the tool glass is controlled by the puck with the left hand, while the cursor is controlled by the other puck or a pen with the right hand. Of course, these are reversed if the user is left-handed. This arrangement makes it easy to have your tools follow you as you move over the artwork, working on different spots. The palette is a tool glass with some click-through tools. For example, clicking through the rectangle tool specifies the starting point of the rectangle, and dragging out specifies the other corner. But notice that the tool glass goes away while dragging, since it's not needed. This keeps the artwork clear, so a new object can be positioned in context. Two hands can be utilized when creating objects. For example, while dragging, the left hand controls the starting point of the object. This allows simultaneous specification of the 3 affine transformations: position, orientation, and scale. Like a traditional GUI, objects can be dragged directly, but in addition, objects can be simultaneously rotated. Furthermore, the center of rotation is specified by the starting point of the drag. Traditional tool modes are available for repetitive operations. Click and holding on a tool locks the tool on the cursor. A small replica of the tool gets attached to the cursor, and the tool can be reused. Objects' properties can be changed by other click-through tools. For example, clicking through the color swatch changes the color of the object underneath. The number of tools available on a tool glass is limited, so a marking menu can be used to rapidly switch between a collection of tool glasses. Note that the menu items are scaled-down images of the actual tool glasses, eliminating the need for custom icons or abstract names. T3 also uses curve guides. A curve guide is a tool that emulates the way rulers, French curves, or friskets are used in illustration. Ink strokes are snapped to the guiding curve. A tool glass can be scaled and oriented. This is particularly useful for controlling curve guides. We can bring up a curve guide, scale and orient it, and then scribe a line along it. T3 saves space by not using scroll bars. When the left puck button is pressed, the left hand can be used to move and rotate the artwork. This rapid panning and orientation of the artwork allows an artist to keep the artwork in a comfortable working position. In addition to panning, the user can zoom in and out by stretching the canvas with both hands. This is done by pressing both puck buttons at the same time. The center of the zoom is controlled by the position of the right hand. A useful artifact is that by pressing the left puck while creating an object, the user can simultaneously pan and zoom the artwork while creating that object. Finally, we are experimenting with using multiple input devices on the tablet where each device has a unique shape and function. For example, switching between a puck and a pen is accomplished simply by moving the new device onto the tablet. Another example is a device we call the flip brick, where flipping the brick changes the tool glass. This allows users to utilize their manual manipulation skills to quickly switch tasks. Thus we see that the tablet is more like a stage in which devices can be easily transitioned on and off the stage. This device shuffling is much easier than, say, recabling input devices and adjusting software device drivers. We now show how the T3 paradigm has been integrated into a product called Studio Paint and the compromises and enhancements involved. Studio Paint is a high-end paint package intended to replace traditional paper and brush sketching tools in graphics design. Its user interface is traditional in many respects, with a few deviations from the standards, mainly to better accommodate the workflow of traditional paint on paper. For instance, commonly used tools can be arranged on a special tool palette called the shelf. T3's techniques could only be added if they integrated smoothly with the existing user interface. Creating a radical new interface would require retraining an installed base of users. Therefore, we had to preserve and also compose with existing modes of interaction. One problem is that the left hand is often used to press hotkeys. We had to provide a way to access at least the most useful functions with the left puck. To meet this constraint, a second button in the left hand was used. This button acts as a modifier, enabling access to a marking menu containing the most useful commands previously accessed using hotkeys. Like T3, another button pans the artwork. We also reused existing components and enhanced their functionality. For instance, using the artist's palette metaphor, the shelf can be controlled by the left hand to pop up nearby where the right hand is working. Notice that if the user is left-handed, the palette will pop up on the right. If the user is right-handed, the palette pops up on the left. The system automatically determines this, and this information can be used to automatically configure other parts of the interface. So far, these designs are mostly aimed at replacing the traditional surroundings of the interface, such as menus, tool palettes, and scroll bars. In addition, based on T3, we have developed design guides such as rulers and French curves within Studio Paint. These types of interactions are common with paper-based tools, but are rarely seen in computer graphics applications. The first step in using design guides is to select or draw a piece of geometry. Here we see standard drawing tools that generate spline-based curves, rectangles, and circles. Note that these shapes can be stored on the shelf for later reuse, allowing the user quick access to reference curves. Next, these design guides can be used to influence inking. That is, instead of free-flowing ink being laid down by the stylus, the guides can be used to snap the ink to the guide. Varying stylus pressure along the path gives a more natural feel to the drawing. These types of subtle interactions are often overlooked in computer-based illustration. The design curves are attached to the non-dominant hand. Thus, the user can translate them at any time. Using both hands as anchor points, the design curves can be rotated or scaled. A design curve can also be used as a mask. Real airbrushes are seldom used without some sort of paper or cardboard mask, often called a frisket. Here we see this style of interaction supported with the non-dominant hand maneuvering the mask and the dominant hand laying down the ink. Again, this is often a very clumsy workflow in traditional paint programs that don't use two hands. Finally, a combination of both snapping and masking can be used to create unique effects, unachievable with paper-based tools. For example, a hard edge can be made to follow the exact contour of a curve. By emulating some of the subtle manipulations used in traditional paper-based graphics design, we hope to improve the quality of interaction in computer-based graphics design.